I want to add all the elements together and I want to divide that value by n. So what is n here? That's nothing but the number of elements. What is xi? That's nothing but 11.4 minus 15. And what's the answer? Minus 3.6. At the same time, what I want to do? I want to find the di square. So what I will do? I'm going to take the square of this data. Hello to all, a warm welcome. The topic is standard deviation. I'm your Revati ma'am, faculty from the Department of Computer Science, Vidhyaashram, first grade college, the Temple of Excellence, MYSURU. So dear student, we are on 4th unit and the topic here is standard deviation. And what are the topics I'm going to deal in my today's session? That is standard deviation. Under that, I'm going to have the group data, ungroup data, and I'm going to have the discrete data. So dear student, let me to explain what is standard deviation. And this standard deviation is a part of statistics. And it is mainly used to find this positive square root. In the sense, I'm going to have the different kinds of data, that is group data, ungroup data, and I'm going to have the continuous frequency distribution. So what is group data? Here all the data are organized or arranged in some order. It is in the form of ascending order. And if I consider ungroup data, all the data are scattered or dispersed. In the sense, all the data are not arranged. And if I consider continuous frequency distribution, then there is a frequency distribution between some elements or some variable. And by using different kinds of method, I'm going to find the standard deviation of group data, ungroup data, as well as continuous frequency distribution. Anyway, dear student, in my today's session, I'm going to deal with only about ungroup data. So here, as the name itself indicates, that data are dispersed. In the sense, data are scattered. Now what I want to do? I want to align the data in ascending order. After that, I want to find out the standard deviation. So what is standard deviation? The aim is to find the positive square root of a given number. Now let me to discuss the calculation of standard deviation for ungrouped data. In that, I'm going to have direct method. Okay, in the direct method, I'm going to have the formula, that is standard deviation, and it is represented by using sigma. Okay, whole square root of, it is summation of xi square. So here, what is xi? What is xi square? That is nothing but xi minus x bar. Okay, now see what is x bar? It's nothing but the mean. And what is the formula to find out x bar? That's nothing but the summation of xi and n. So what is summation of xi? That is nothing but the, I want to add all the elements together and I want to divide that value by n. So what is n here? That is nothing but the number of elements. So here, summation of x square I by n minus whole square of summation of x minus n. Now, this is the formula used to find the values directly, in the sense by using direct method. So this is the first type, comes under standard deviation for ungrouped data. So dear student, let me to consider this example. See here, I have some set of data. Okay, and if I see this data, how the data are organized? Data are scattered. Now what I want to do? This is nothing but the mixed data. Now what I want to do? I want to align the data, or directly I can able to substitute the formula. So here, what is the formula? To find out direct method, that is sigma. So this is the formula used to find the standard deviation by using direct method. Now, if I consider this one, what are the things I required? I required xi square. So what is xi square? That is nothing but xi square xi minus x bar square. So what is the value to find out mean? That is summation of xi by n, and it's a direct method, so no need to find out the mean. But what I required here? I required xi square. So what I'm going to have here? I'm having xi. Okay, and if I take the square of that is 13 into 13, 169, then 8 square, 64, 4 square, 16, 9 square, 81, 7 square, 49, 12 into 12, it is 144, and 10 square is nothing but the 100. Now what I want to do? I want to find the summation of xi as well as summation of x square I. And what is the summation of xi? That's nothing but the 63. And what is the summation of x square I? That's nothing but the 623. Now I got the required data. So I got xi square and xi. And I'm going to substitute. Okay. After simplifying this one, I'm going to get square root of 89 minus 81, that is nothing but the square root of 8. And when I take the square root, I'm going to get the standard deviation, that is 2.83. So dear student, this is the direct method, so no need to find the mean. If in the question, if we get find the mean, then you have to find. But this is a direct method, so no need to find the mean. Directly, you can substitute the values for the given formula. According to the variable present in the formula, I want to find the values. And if I consider this formula, I have xi square and xi. So I have xi and I want to find out xi square. Now I'm going to have another method, that is nothing but the mean method. Okay, so under group data, we are going to have 4 different methods. One is direct method, another one is mean method, and another one is step deviation method, and the last method here is assumed mean. So dear student, this is the another type of standard deviation for ungrouped data. So another convenient way of finding standard deviation. And what is the formula? That is whole square root of sigma or summation di square divided by n. And what is di square? That is nothing but xi minus x bar. It's nothing but the xi minus x bar. So it is di. Suppose it is d square I, then it is also square. Okay, and what about n? That is nothing but the number of elements. So dear student, if I consider this example, so let me to read out this example. the amount of rainfall in a particular season for 6 days are given below. Okay, and the rainfall is 17.8 centimeter, then 19.2, 16.3, 12.5, 12.8 and 11.4 centimeter, and find its standard deviation. Okay, see, all the data are not in a group. What I will do, first I am going to align the data in some order. Okay, I am going to organize the data in ascending order. Okay, now how many elements I have here? That is total 6. Now I want to find out the mean. And what is the formula? Sigma xi by n. And if I add all the values together and if I take the summation, what is the answer I'm going to get? I'm going to get the answer 15. Okay, now see here. I'm going to have the table here, and xi is nothing but the given data, and I have to find out di. And to find out di, what I required xi minus x bar. So what is x bar here? That is nothing but the mean. And what is the mean here? That is 15. So what is xi? That is nothing but 11.4 minus 15. And what is the answer? Minus 3.6. And here it is 12.5 minus 15. The answer is minus 2.5. Next I have 12.8 minus 15. Answer is minus 2.2. Next element 16.3, then minus 15, then the answer is positive 1.3. Now 17.8 minus 15, answer is 2.8. Here I have 19.2 minus 15, the answer is 4.2. Now what I want to do? I want to have di square. So I am going to take the square root of these values. And when I take square root of these values, I am having 12.96, 6.25, 4.84, 1.69, 7.84 and 17.4. And what's the formula? That is whole square root of summation of di square by n. So I required summation of di square. I am going to add all the values. And what is the value? I am going to get 51.22. Now I am going to substitute the values in the equation or in the formula. So whole square root of 51.22 by 6. Okay, and when I simplify, I'll get square root of 8.53. And if I take the square root of 8.53, my standard deviation is 2.9. So what is standard deviation? It is mainly used to find the positive root of a given number. Now, I have another method called assumed mean. So, as the method itself indicates that I am just going to assume the mean. If I consider previous example, okay, I am going to have the mean value. And there are certain time I am going to get the fractional mean. In the sense, I am going to have the decimal points, okay, mean in the decimal point. By using this, it's very difficult to calculate the mean. So what I'm going to do, I'm just going to assume the value. For that reason, it is called assumed mean method. So when the mean value is not an integer, so if I'm not getting any whole number, say 10 or 20, okay, then it is difficult to find the calculation. For example, think that I have 25.125. See, this is the decimal fractions. So it is very difficult to perform the calculation and very tedious in decimal form. Then it is better to use assumed mean method to find out the standard deviation. In the sense, I am going to assume the mean which is nearest to the mean value. Okay, so I am going to consider only integer values and I am just going to assume. So here I have series of data, that is x1, x2, x3 up to xn with the given data value. Then x bar is nothing but the mean and the standard deviation here is sigma equal to whole square root of summation of di square by n minus whole square, that is sigma di by n whole square. Okay, now this is the formula used to find assumed mean. In the sense, I am going to find the standard deviation of a given data by using assumed mean method. Now, I am going to have the example problem, that is the marks scored by 10 students in the or in a class test are 25, 29, 30, 33, 35, 37, 38, 40, 44 and 48. Now I want to find the standard deviation. So dear student, if I go with mean method, okay, what is the mean I am going to get? That is 35.9. By using this, it is difficult to perform the calculation. So what I am going to do in the given data, I am going to see which value is nearer to 35.9. And if I consider, I have 35 and I have 37. So what I will do, I am going to consider 35. And what about n? N is nothing but the total number of values or total number of data. Now let me construct the table. See here, first I want to write the xi value as it is. Okay, then I want to find di, and what's the formula? To find out di, I have xi minus a. Instead of x bar, I am going to have a. What is a? That is nothing but the assumed mean method. Okay, and here 25 minus 35, it is minus 10, 29 minus 35, minus 6, 30 minus 35, minus 5, 33 minus 35, minus 2, 35 minus 35, it is 0, 37 minus 35, it is 2, 38 minus 35, it is 3, 40 minus 35, it is 5, 44 minus 35, it is 9, 48 minus 35, it is 13. Now what I want to do? I want to find the summation of di. At the same time, what I want to do? I want to find the di square. So what I will do? I am going to take the square of this data. So minus 10 square, it is 100. 6 minus 6 square, it is 36. I want to add all the elements together and I want to divide that value by n. So what is n here? That is nothing but the number of elements. 5 square 25, 9 square 81 and 13 square it is 169. Now dear student, I want to write the standard deviation formula. Okay. Now, see here, what is summation of di square? That is nothing but 453. And what about di, summation of di? That is nothing but the 9. And what about n? N is nothing but the total number of data. So, it is 10. And when I simplify this one, I'm going to get square root of 45.3 minus 0.81. And further, if I simplify, I'll get minus 44.49. And okay, when I take the square root of this element, I'm going to get the standard deviation, that is sigma equal to 6.67. Now, dear student, I'm going to have my fourth step or fourth type, that is step deviation method. In the step deviation method, I'm going to find the common factor. In the sense, I want to find the C. C in the sense what? The common factor. Okay. So, by the common factor, I can able to multiply all the numbers. So, here let x1, x2, x3 up to xn be the given data. Then let A be the assumed mean. Okay, and the formula here is C into whole square root of sigma di square by n minus sigma di by n whole square. Okay, now C is nothing but the step deviation. In the sense, I want to find out the common factor. Now, I have the example here. The amount that the children have spent for purchasing some eatables in one day trip of a schools are, see here, all the datas are arranged. 5, 10, 15, 20, 25, 30, 35, 40. Using step deviation method, find the standard deviation of the amount they have spent. Okay, here we note that all the observations are divisible by 5. So, I have all the numbers multiple of 5. In the sense, it's nothing but the divisible of 5. And what is the common factor C here? That's nothing but the 5. And what about assumed mean? Okay, here the assumed mean is 20. And what about n? N is nothing but the number of data, that is 8. Okay, now what I want to do? I want to construct the table. And what are the things I required according to the formula? I require di square and di. So, what I will do? First, I will write the values as it is. Then, I'm going to find out di. So, it is di minus 35. So, now I have n is nothing but 8. Okay, now it is 8. What's the value of n here? It is nothing but 8. In the sense, total number of data present in the given data set. Now, dear student, what I want to do? I just want to find out the standard deviation. And what is my assumed mean? That is 20. And what are the things I required? I required xi, di and di square. Okay, now to find out di, I have the formula xi minus a. And what is a? That is 20. So here xi is 5. 5 minus 20, I'm going to get 15. Then 10 minus 20, it is minus 10. 15 minus 20 minus 5. 20 minus 20, it is 0. 25 minus 20, it is 5. 30 minus 20, it is 5. 35 minus 20, it is 15. Then 35 minus 35, it is 15. Then 40 minus 20, it is 20. Now, what I want to do? I want to take the summation. At the same time, see here. Okay, I have the formula, that is di equal to xi equal to a by c. C is how much? It is 5. So, I have 15 divided by 5, it is minus 3. 10 divided by 5, it is minus 2. Here it is minus divided by 5, it is minus 1, and I am going to continue. Okay, now what I want to do, I want to take the square root of this data. I want to take the square root of di. So minus 3 square, that is 9, minus 2 square, that is 4, minus 1 square, it is y, minus 1 square, it is 1, and I'm going to continue the calculation, and at the end, I'm going to find the summation of di square equal to 4, and here also I'm going to find the summation of di equal to 4. Now, dear student, I have the formula. For this formula, I'm going to substitute the value. Okay, and after substituting the value, I want to get the standard deviation. And here C is nothing but the common factor. And what is the common factor? It is 5. So what I want to do? I want to simplify the data which is present in the square root. Okay, after taking the square root, I want to multiply that value with C. C is nothing but the common factor 5, and I'm going to get the answer standard deviation equal to 11.45. Now, dear student, I'm going to have few more example problems. So here, calculate the standard deviation of the following value by using actual mean method, assumed mean method, direct method, and step deviation. And what is the data? That is 5, 10, 25, 30, and 40. So this is the actual mean method. So what I want to do? I want to construct the table. So 5, 10, 25, 30, and 40. And what is the summation of x? That's nothing but the 120 divided by 5. That is nothing but my mean. So mean is 24. Now see here. I have 5 minus 24, that is minus 19. 10 minus 24 minus 14. Then 25 minus 24, 1. 30 minus 24, it is 6. 50 minus 24, it is 26. Now I want to take the square of that. So square of 19, 361, square of 14, 196, square of 1, it is 1, square of 6, it is 36, square of 26, it is 676. And what is the summation of di square? That is 1270, and I'm going to substitute the values to the formula. And when I take the square root of that, I'm going to get the answer. This is the standard deviation. And what is the standard deviation? That is 15.937. Now, see, I want to solve same data by using assumed mean. Okay, see here. What is the assumed mean I'm going to have? That is 25. I'm going to assume that the mean is 25, and see here, I'm going to have the d and d square. Okay, 25, that is 25, 5 minus 25, it is minus 20, 10 minus 25 minus 15, 25 minus 20, it is 0, 30 minus 25, it is 5, then 50 minus 25, it is 25. Okay, when I perform the summation of di, answer is minus 5. Now, I want to take the square of d. Okay, minus 20 square, it is 400. Minus 15 square, it is 225. 0 square, it is 0. 5 square, 25. 25 square, 625. And when I add all the values, I'm going to get 1275. Now, I have the formula, and I'm going to substitute the values here. And when I substitute the value and when I simplify this one, I'm going to get the answer 15.937. Even, dear student, you can cross verify. If you go with the standard mean method, okay, that is the mean method, then I'm going to get 15.937. Here, I'll get once again same answer, that is 15.937. Even though if I consider mean method or assumed mean method, whatever the standard deviation I'm going to get, that is same for both the method. Now, calculation of standard deviation by using direct method. So this is the direct method used to find out standard deviation. Okay, in the direct method formula, I have sigma x square. So I required x square. I have the x and I want x square. So what I will do? I'm going to take the square. 10 square, it is 100. 25 square, it is 625. 30 square, 900. And 50 square, it is 2500. And when I take the summation, I will get 4150. Okay, now I'm going to substitute the value in the given equation. Okay, so here 4150 by 5. And what about this x bar? That is nothing but the mean. Okay, to find the mean, what I want to do, I want to add all the x values divided by 5. So dear student, what is x bar? That is nothing but 24. Now what I'm going to do, I'm going to substitute 24 in the formula. It is 24 square. And when I take square root of, that is whole square root of 4150 divided by 5 minus 24 square. Okay, after simplifying this one, I'm going to get square root of 254. Okay, when I take the square root, I'm going to get the answer 15.937. So dear student, if I use direct method or mean method or assumed mean method, I'm going to get the same answer. Anyway, dear student, in my today's session, I started with standard deviation. Under that, I have discussed mean method, assumed mean method, direct method and step deviation method. And from the examination point of view, all these topics are very, very important. And in my next session, I'm going to deal with standard deviation. That is nothing but ST for group data and standard deviation for continuous frequency distribution. Anyway, dear student, let's meet in the next session with the new concept, with new example programs of standard deviation. Until that, keep watching and keep learning. Thank you.